Relatively short lesson today, second half of 7.3, working with parallelograms, improving something in parallelogram. We're going to work in the coordinate plane, and we're going to start with this question right here for a very quick, just check up, remembering the distance formula. So go ahead and solve this problem. Okay, looking at the parallelograms, hopefully you got that question right. How do I show that something's a parallelogram in the coordinate plane? Now, there are a lot of different ways we can do this. We have a lot of choices because we have all the different ways of proving something's a parallelogram. We could choose to prove both pairs of opposite sides parallel. In order to do that, we'd have to do slope formulas for all four sides. We could choose to show that both sides are congruent. To do that, we'd need distance formula. We could show that one pair of sides is both parallel and congruent. That would mean a slope and a distance formula for the same pair of sides. Or we could show that the diagonals bisect each other. And that would involve midpoint formulas. Now, you're going to be expected to demonstrate multiple techniques. By far the easiest technique we can use here is this one. That's the quickest because it only requires us to show two equations. If I can show that the diagonals have exactly the same midpoint, that proves that it must be a parallelogram. So all these other require, this requires four formulas, this requires four formulas, this requires four formulas, two slope, two distance. This one only requires two. So that's the easiest way, but again, it'd be expected that you're going to have to demonstrate more than one method. You can't just use the same method over and over and over again. So I'm going to expect you to be able to demonstrate more than one. But let's go ahead and do this one this way. Let's show that it is a parallelogram by showing the diagonals bisect each other. Simply what we'd say is, again, explain what you're finding. Midpoint of AC is at, and then do your coordinates. It's -3 plus 5 over 2, and 3 plus 2 over 2. -3 plus 5 is 2, 2 over 2 is 1, 3 plus 2 is 5, 5 halves. And then we'd say midpoint of BD equals, and again, 2 plus 0 over 2 and 5 plus 0 over 2. So that's 2 over 2, which is 1, and 5 over 0, which is 5 over 2, which is 5 halves. Okay, since it's same, then you'd have to state your conclusion. This proves diagonals bisect each other. So we do our calculations and we write a conclusion. Don't just do the calculations. Don't just say, oh, they have the same midpoint. You have to prove it, okay? We aren't writing two-column proofs here, but you actually have to prove it by demonstrating what it is you're measuring, okay? Midpoints, we're saying what we're measuring, and then stating a conclusion about what we found. So that would by far be the easiest way to prove that's a parallelogram. Okay? So here's our next question. We're going to do another example in just a minute. What formula to use to show that two lines are parallel? Just a real simple question. Answer it. Okay, now that we've done that, let's show that JKLM is a parallelogram using a different method than the one we've used before. Well, we're first going to want to come up with our coordinates for our points. K is at negative 1, 2, 3, 4, negative 4, 1. L is at 2, 3. M is at 3, negative 3. And J is at negative 3, negative 5. 1, 2, 3, 4. Yep. Okay. I want to prove that this is a parallelogram using a method different than what we used here. So we used diagonals bisect already. We need to choose both pairs of sides parallel, both pairs of sides congruent, both pairs of sides, one pair of sides parallel and congruent, or whatever else. Okay? So again, it's kind of up to you to choose what method you'd use in a situation like this. Since I'm choosing right now, I'm just going to do with the definition. I'm going to say, prove that the opposite sides are parallel. So what am I going to measure? Again, write out what you're doing. So we're going to say the slope of KL. Write it as what you're finding and do the calculation. Equals y2 minus y1, 3 minus 1, over x2 minus x1, 2 minus negative 4. Simplify it. 3 minus 1 is 2. 2 plus 4 is 6, so that slope is 1/3. Then we find the slope. Now I'm going to do the opposite side right away so I get the parallel slopes. Slope of JM. So negative 3 minus negative 5, y minus y, over 3 minus negative 3, x minus x. Negative 3 minus negative 5 is 2, because negative, and 3 minus negative 3 is 6, so that's 1/3. Aha. What does this show us? This shows us that KL is parallel to JM. So we did our calculations, we noted, and we made a conclusion. That doesn't prove it's a parallelogram yet. That's just one pair of opposite sides. Now I'm going to find the slope of JK. No, I'm not kidding about that. So that'd be negative 5 minus 1 over negative 3 minus negative 4. So negative 5 minus 1 is negative 6. Negative 3 plus positive 4 is 1. That slope is negative 6. And the slope of LM. So that would be negative 3 minus 3 over 3 minus 2. Negative 6 over 1 equals negative 6. Aha. Those are the same, which tells us that JK is parallel to LM. That's great. Now we state our final conclusion. We've got all the evidence we need. So both pairs of opposite sides are parallel. And that would be a proof that that is a parallelogram. So we do have to be pretty explicit about how we explain things. We have to go through it and definitely go step by step. Show our calculations, state what that calculation is telling me. Show our calculation, state what that calculation is telling me. I could have done it exactly the same way, number 8 here. What other methods could I have used? I could have stopped here. Instead of doing the slopes of JK and LM, I could have done the distance, the length of KL and JM, and one pair of sides, both parallel and congruent. Or I could have done all 4 distance formulas show that opposite sides are congruent. Get used to using these formulas. We're going to use them a lot, especially in the second half of the chapter when we start getting into special types of parallelograms. This is a great way to distinguish exactly what kind of parallelogram we have in the coordinate plane, or if it's not a parallelogram at all, or anything else. We're going to be using these formulas, so be very, very comfortable using them. And also be very comfortable explaining carefully in your work what is going on. I'm not going to accept just like, oh, yep, they're parallel, or just final solutions that have just the slopes listed. Okay, I'm going to want to see what you're setting up. I'm going to see you set it. I want to see you set it up and state your conclusions. Organize and communicate what you're doing. That's such a critical portion of anything that we do in mathematics, is the communication of what it is you're doing. It tells me you really know what you're doing, and it also helps you because if on a test you were doing something like this and you made some small arithmetic error, say you made an error here and you accidentally put 3 minus 1 and came up with 4 over 6 and you made a bad conclusion, but you showed all of this work, you'd still get the vast majority of the points. That'd be maybe a half a point off type of situation because you showed me exactly what you're doing. So showing your work doesn't just help me read what you're doing, it helps you because if you make a tiny mistake, it doesn't cost you as much because I can tell you understand the main concept. So be showing your work, know your distance, midpoint, slope formulas, be prepared to use a variety of methods as you're doing this. All right, that ends this. We'll be heading into our quiz next, so hope you're preparing, studying, and be sure you grab a review sheet. See you in class.